Good evening, everybody. Welcome to Shop Talk. Today is September 28th, 2020. To my right, I think it is, we have the invisible Mala Mahadevan.
Hi, good evening, everyone. Sorry to be invisible today. Got some stuff going on.
Yeah, Mala is currently working undercover for a three-letter agency and is in a remote region that she can't tell us about. So that's stream canon reasons for why camera's off. Tom could not make it tonight. I believe he is currently wrestling bears. So if you see him, yeah, he's got to like they're tag teaming. It's just bears cheat a lot. Halloween invisibility cloak. Maybe next time. I got to remember that one if I can remember that one. So, tonight, start talking about Azure because we've got breaking news, which really it's not breaking, but actually it's all about broken news. Azure Active Directory looks like that service is currently down and causing a bit of problem for people on the internet. Like, you can't get into Teams, you can't get into your services, you can't get into the Azure portal. The Bears, technically, Anders, it is Da Bears with DA. And Da Bears don't need to cheat. They had Jim McMahon. So, Azure Active Directory currently down, causing some issues for people. Dogs and cats sleeping together, all kinds of chaos. So I wanted to take that and, ask, well, what do you do if you rely on a cloud service? Your company depends on Azure or AWS or whoever being available. Whoever, could be Google, could be Rackspace, could be Alibaba, whoever. What do you do at this point? I mean, how do you build resiliency when you do rely on a cloud service? And I wanted to take a moment, especially picking some brains in chat, get an idea of the types of ways that you as an IT professional can sort of cover your company, help your company keep going even if these cloud services are down. And Raymond mentions failover. Failover is a really good option. So if you have on-premises SQL Server, for example, I could have an availability group. I could fail it over. It's a distributed availability group. I could fail it back to another data center. You could have cross-cloud. Go to the liquor store and prepare for a long night. That's the practical way. You could potentially go cross-cloud. You could have services in Azure and AWS. Use one as a backup for the other, or even load balance across them. This would require a lot of development effort, I would think. Because, if you think about, say, just strictly, say, web services, all right, that's not horribly difficult. I can have web servers in AWS, web servers in Azure, web servers in Rackspace. Yeah, deploying out is a little bit different, but I can configure them reasonably easily and live mostly off of Docker images. Like here's my Docker image that I can deploy to Azure, to a container repository, spin up as an Azure website, have it going. You could have containers in ECR for Elastic Container Repository for AWS, deploy those out as either EC2 instances built off of the container or as just images that are deployed using, say, Elastic Kubernetes Service. And follow that downstream with other sources as well. That can kind of cover you for web servers. When you start talking database servers, it gets a bit trickier because, I expect my databases to be reasonably fast. And if we start talking about an availability group, especially a synchronous availability group that crosses clouds. Technically possible, practically not sure I would want to do that. Even if you are co-located in a data center that has direct connections to Azure and AWS data centers, that's still some hopping that I don't necessarily want to add when having to commit any transaction. Anders says SQL, Active Directory, mid-tier web servers, Office 365, all in Azure. And if you have Active Directory in Azure, yeah, if you're using Azure Active Directory, which generally I would say go ahead, do that. It's generally a really good idea. But right now, it's not a good idea. We had another case of this last year where Azure DevOps went down for a while. And we learned later on that Azure DevOps was hosted generally in South Central US and didn't really have anything anywhere else. We've seen cases where AWS regions have gone down, where services like S3 have been unavailable. And the real question, yeah, I would agree. How many nines do you really need? For some companies, the answer is quite a few. Quite a few nines. For a lot of companies, if the website is down for an hour, you don't necessarily want it to be down, but it's not the end of the company. It's just basically, oh, well, shucks, I guess I'll do this later. Netflix was down when the AWS region went down. Now, Netflix has a lot of tooling that is able to handle going across regions, specifically because they were down because AWS went down one time. So you can try to do cross-region resiliency. You could have backup data centers. I guess it depends in large part on how much you need to be on right now. How much money is it costing you? And if it's costing you a lot of money, that's where you start saying, yep, we're going to have that extra data center. Yep, we're going to be constantly log shipping. We're going to do everything possible to get as much data to as many distinct regions as we can and have services that are fairly resilient to failure. Services that are non-cloud based, backup methods that we can get out just in case there's a major travesty. Everyone needs 6 nines until they see the bill. Yeah, exactly. At that point, they say, well, maybe I only need 90%. 90%'s cheaper. And I need 6 nines, but I don't want to pay for failover. I don't want to pay for redundancy. I don't want to pay for geo-regioning or for any sort of redundancy at all. Nah, just click the cheapest option. Give me the free tier. I'm sure that'll be just fine. But in this case, I mean, it is interesting that if you're not using Azure Active Directory, if you just have a website that is publicly available, it looks like that site is still available to you. Or if you have virtual machines that you don't use Azure AD to connect into, looks like those are currently available based on the Azure status page. So much of services are currently capable, but if you want to connect to anything and you need Active Directory, that's a tough one. Enhanced QC says Twitch can run on T2 Micro, right? Yeah, I'm sure. No problem at all. Why not distributed AD controllers on Raspberry Pi clusters? That's my answer. If you change that from Pi clusters to real servers, yeah, you could, and that might be a reasonable option where you say I can integrate on-premises Active Directory with Azure Active Directory. So if I have services that are potentially available online and offline, or when I say that, I mean in Azure and on premises in a data center someplace, it might be as simple as flip the switch and we're going to use our on-prem servers. We're going to use those on-prem web servers. We'll update DNS and go forward. Or you might say, well, we have stuff currently in AWS. It's all shut off because that's our failover option. Spin up those servers. Time to fail over. There's some stuff that is really difficult to do, though. Like, if you think about one of the major benefits you get from Azure, from AWS, is platform as a service. I can't easily switch from all of my data is in Azure SQL database, or it's in Cosmos DB, and suddenly have it be available in RDS or DynamoDB. It doesn't really work that way unless I'm pushing to both simultaneously. If you are pushing to both, then okay, though you've increased your bill rate significantly, and you can't turn those services off, and you have the possibility of data that made it to one but not the other. So then you have validation scripts, you have needing to check both of them to make sure that all of the sources are reporting the same data. And it's not trivial. It's possible. Nothing I've said is magical or you can't do it at all. It's just, is your company willing to pay that much money for it? And for a lot of companies, no. Like, even mid to large size companies, I'd say no, they're not willing to pay for it. Yeah, it is a lot of dollars once you start talking about, well, if I'm paying this many hundreds of thousands of dollars for Azure, I then have to pay this many hundreds of thousands of dollars for AWS, and the best thing that you're giving me is I can potentially make services faster on a regular basis and can deal with a major outage, potentially could deal with a major outage. A lot of companies will look at that and say, just not worth it. We'll save hundreds of thousands of dollars for just shutting this thing off, and cloud services never go down. It's okay. Azure will give me a credit if the service is down. So you'll get to save 45 cents on your Azure Active Directory cost. Similarly, when S3 went down for 6 hours in the East region, yeah, people got their $1, $2 credits because the downtime was above that threshold. But I don't know. It's a tough call. I mean, it is going to come down to what makes financial sense, and for most companies, I don't think it makes financial sense to try to be ultimately survivable. You have some level of resiliency. Like Anders mentions, 2002, his company spent $2 million a month on resiliency as a result of 9/11. And there are times when, you know what, if you work for a company where if you're down, it is now $10 million a month if you're down, versus a $2 million per month cost if you're to make sure you don't go down, you can make those calls. That's what insurance is for. Yeah, you'd have to be very clear about the insurance policies, because there are people who are much better about it than I am. I'm not going to pretend that I know much of anything about insurance, except that those policies are written in a very clear, in a very specific way, and it may not be clear immediately whether or not a specific thing is covered. Cyber insurance, Enhanced QC says most of it is for breach activity. Yeah, yeah, generally cyber insurance is, I have a data breach, and this is going to cover giving people 1 month of credit monitoring or whatever minor token thing they do. And if you have, say, outage, some type of outage insurance, you want to make sure that it actually would cover the scenario. I mean, they may say, well, you know, the servers were still up, so we're not going to pay the insurance just because your Active Directory instance was down, because people could still get to the web page. You couldn't actually do anything at that time, but, you know, your website was still up. Lloyd's will cover anything for the right price. almost anything for the right price. But again, the terms and conditions of the policy are what make that critical. So Mala, I've been ranting. I've been on this. What are your thoughts?
What are my thoughts? I don't have much Azure experience to weigh in on it. That's why I was rather quiet. Um, oh boy. Honestly, I'm not sure I have too much to contribute here.
That's
I
fair.
haven't experienced this kind of situation where you have your stuff in a cloud, and I mean, I've had outages with Office 365 and other hosted stuff, which has been, bad. At one place I worked at, it was pretty bad because they relied heavily on Excel and various for that. But
Hmm.
that's somewhat different from this. I don't know. I don't have much to contribute this there, just because I have no experience with this. That's all.
Yeah, yeah. Well,
Yeah.
even software as a service outages, those happen. We saw Azure DevOps go down.
Mm-hmm.
You just mentioned Office can go down. If
Mm-hmm.
you think about, we don't most of what happens in Microsoft Office nowadays is online. So
Mm.
it's gone are the days of Office 2003 when I just had
So I've been
everything.
in debates on this, though. I hate to say, at Summit, I think last year there was some kind of a panel debate discussion, something where Microsoft people were arguing pretty strongly the lines that if you have your own server, your own in-house server, have you ever worked anywhere where that never goes down? So, you know,
Yeah,
just because it's hosted, it doesn't mean that, that it is 100% foolproof and things like that. So that was one argument that I heard, that it does go down even if you own it. Doesn't mean that, you probably have some control over the reasons, but it still does happen.
sure. Hey, that's
Check.
that's a valid point. I mean, same thing with Exchange servers, where
Mm-hmm.
Exchange servers fail, and being an Exchange administrator, you can easily take down Exchange. Um, that's the only thing 100% guaranteed is failure. I like that. Let's see. Anders says so far we've had 12,000 plus backups fail because of it. Those weren't really important backups. And Raymond says that customers may not agree with your assessment. Yeah, that's customers for the customer. It's anywhere from this is a nuisance to uh, potentially a major issue. I mean, it might be. I tried to go to your website to buy something. Your site wasn't up because or wasn't available to me, or I couldn't log in, and therefore I decided to buy it from somewhere else. It's one of the reasons why, say, Amazon puts so much money, effort, and development talent into making sure that that cart, if your cart fails, if they have some sort of issue where your cart has failed, a lot of stuff has gone wrong along the way,
Mm.
and that's that makes a lot of sense when you're talking about the scale, just the number of sales that they could lose simply by being down for a few minutes.
Mm.
So I wanted to switch gears a little bit. Anders, by the way, mentioned the time that found a bug in SQL Server 6.5 because he kept the server up too long. Well, you got to reboot those servers every day. Good old Windows 95 advice. Uh, I blame Agile for this entire thing if it was a software upgrade that caused it. Even if it wasn't, I think there's at least a 30% chance you'd still blame Agile for it. So the next thing that I wanted to talk about was hello, welcome to Shop Talk. I kind of jumped right into the Azure Active Directory outage. I was looking at the status page, seeing some crazy stuff online, and figured I'd lead off with that. Um, Shop Talk is community driven, chat driven, hosted by the Triangle Area SQL Server Users Group. I've already introduced Mala, and I think I've introduced myself, but if not, I'm on the internet. And the way this normally works is, we've got a couple of topics that we keep in the bag just in case chat is quiet. But if you have questions, thoughts, definitely interested in talking about that. And as I wait for, if there are any questions, drop them in chat. We'll talk about them for sure. But I do want to talk about one of my favorite wait types, SOS scheduler yield. So, doing a bit of consulting work, and customer of mine looked at their wait stats. By the way, let's talk about wait stats for just a moment. I'm going to give the extremely brief version. I will drop into chat Paul Randall's seminal article on wait stats, and that also leads to some, I believe there is a white paper that is attached on here, which talks about wait stats in much greater detail. But the gist of it is, I have a query that's running, and the query is going to be in one of a few states. One of those states is it's running. It is actively using CPU. It is currently doing its thing. It runs for 4 milliseconds, which is the quantum. This is the amount of time that's allowed to run. And then scheduler pulls it off. Very briefly, very, very vaguely, high level. I know there are a lot of details in here that I'm skipping, and heck, I probably got something wrong already. Them's the breaks. What happens when you wing it? But anyhow, that's the ideal state. You wait. You're in a queue. That's the runnable queue. Hey, I'm ready to go. You run for a few milliseconds. You get pulled off the queue. The running state back put onto the runnable queue, and that goes. Now, sometimes you're waiting for a resource. For example, I am waiting for access to a page on disk, and it is currently locked by some other process. Something else is running that has locked because it might be trying to update that page on disk. So I need to wait for it. Well, we now have a wait. I can't go onto the runnable queue because I don't have what I need to run. So that process basically puts up, hey, I am waiting for this resource. And once that resource is available, then I can become runnable again. So wait stats essentially give you an idea of what the problem is. Why are you waiting? And a lot of what it comes down to is what resource is most limiting on your server. So there are different wait types that are responsible for different things. Anders mentions CX packet. CX packet's a really good one. Basically, prior to SQL Server 2017, I think it was CU1, and SQL Server 2016 SP2, somewhere around there, CX packet basically meant there's parallelism. There are queries that are going parallel, which, if you think about it, isn't really a bad thing in and of itself, because it just says, hey, I'm making good use of available CPU cores. Now, it can lead to problems. Like if I have 16 cores and I have one query that's taking up 16 cores, and I have another query that wants to use 16 cores, both of them can't run at the same time. So one has to wait for the other to finish. It's asking for cores. Can't get those cores yet. The other one is currently running. Now I have a wait. Now I have a bit of a problem. CX packet, like I said, just says I'm running parallel. Now, newer versions of SQL Server split this up into two different waits: CX packet and CX consumer. Where CX consumer is the benign wait that I mentioned, that yeah, this is just, I have a thread that's gone, process that's gone parallel. I have multiple cores available for this operation. Life is good. It's doing work. CX packet becomes, uh, due to probably something like bad statistics, I am seeing one core working while other cores are finished with their work. Those other cores have to wait. They've already completed their data, the data that was spread out for them, but this one is still going. So we have to wait for it to finish before we can continue on. That's a bad wait. The fix for that, by the way, is not to set max degree of parallelism to 1, not to force yourself out of a parallel query. That's generally not the best solution. So Anders says, actually had a server where CX packet was not number 1 last week. It is uncommon. I never met a SQL problem that wasn't fixed by more RAM. More RAM is often the solution. Anders had a few environments where more RAM did not speed it up. Yeah, if you're in a case where you have, say, more RAM than you have databases, so you have 10 gigabytes worth of data stored in files, and you have 128 gigs of RAM, and your queries are slow because they're just really bad queries, more RAM's not going to help you. That's obviously an extreme scenario, but it's one of the most obvious. Anders gives another case where you have a lot of blob data, which that blob data you're going to be reading from disk. It's not going to be held in the buffer pool, so you're not really getting to take advantage of RAM that way. What I wanted to get at, though, was the customer had an interesting mix of weights. So I'm going to come down here and see if I can possibly share my screen without completely having everything fall apart. Gosh, look at that. I actually got it to run. So over here in Azure Data Studio, this is a query that Glenn Berry puts together. So Glenn has a great set of diagnostic information queries, keeps them up to date. Here is the latest version, September of 2020. And one of those queries is around tracking weights. And by the way, there are a lot of weights that are included in this list that is specifically don't even look at it. So for example, CLR manual event. Basically, this query is something Paul Randall put together originally, and he included a lot of weights that are perfectly benign. Broker receive wait for is a great example of a perfectly benign wait. You have a process that is running that is just waiting for a message. There's nothing it can do until it receives a message from Service Broker. So if you don't have messages going through, yeah, this wait is going to increase. It can get very large, but it doesn't matter. It's not actually preventing anything from running. It's not actually slowing down a system. So it's one that you can safely ignore. Coming back, let me run this query. And we can see that on my machine. Now my machine is a desktop. I've got just a SQL Server that I do some crazy stuff with. And external script network IO is number 1. It is responsible for about 75% of weights. So if I'm looking at this, external script network IO and satellite service setup are both related to SQL Server machine learning services. This first one essentially says you have an R or Python script running. And the second one says you want to contact the Launchpad to have it spin up R or Python in order to run a service. And notice that when it does wait, we're waiting for about 1 second, half a second. So not a lot of stuff going on in this machine. And that's not too crazy. It's a local SQL Server installation. And I've rebooted it in the past several days. But this is a fun screenshot. The top 2 CX packet and SOS scheduler yield. So I mentioned CX packet, parallelism. The other one, SOS scheduler yield. The initial reaction when people read about this is, oh, you've got CPU problems. But going back to Paul Randall, drop that link in for chat. SOS scheduler yield doesn't necessarily mean that you have CPU problems. Essentially, scheduler yield says, I have spent the entire 4 milliseconds that I'm allowed running on this problem, and I have not had to stop to get more data. I've not had to stop to gain access to a resource. I've not had to stop because of memory constraints or any other reason. I've not stopped because the query's finished. I've just exhausted my 4 milliseconds, and now I'm done. So we wait SOS scheduler yield until I can be put back and run again. If that's the reason that you get scheduler yield, that's normal. It is potentially a problem where, say, you're scanning too much data. You're scanning a lot of data. You know, you're not blocked in anything. It's getting the pages. You're not having to stop for anything, but you may be doing more work than you need to. And scheduler yield could, in that case, be an indication that, oh, I can tune some queries. There is an exception. That exception comes from signal weights. So the signal weight here, signal seconds, is when you are essentially you're waiting for CPU to become available. Now, the rule of thumb with scheduler yield is a rough rule of thumb. About 20%. If this number, signal seconds, is more than about 20% of the wait seconds, then that's an indication that, yeah, there's some CPU waiting. You're waiting for cores to become available. And you can see in this case, the number is essentially 100%. So we are constantly waiting for cores to become available. And the reason for this is that I have several queries running, each of which wants a certain number of cores. And let's say that the number is 4. Let's say we have 16 cores, and we have queries running. They all want 4 CPU cores. They want 4 CPUs. The problem is that once I get 5, 6, 7 of those queries running concurrently, I may have currently running all 16 cores on certain resources. Certain things are running, and I have to wait until 4 cores are available before I'm allowed to be runnable. This gets worse if I have one query with a degree of parallelism of 8. So now I have to wait for 8 of those 16 to become available. And if I have another one that's 16, I have to wait for all of them to become available. So as you have greater degrees of parallelism as a percentage of your total number of cores, you're more likely to see this sort of signal weight, where we have to wait for enough cores to be available. This is not special to SQL Server. It's not special to databases. Like if you look at VMware, you could have hosts, and you have, say, an ESX host that has 100 cores. Nice round number. You can allocate that up among virtual machines. And one of the rules of thumb with core allocation is that generally don't want to go above 1. So you can allocate 100 vCPUs across that ESX host in however many virtual machines you want. But as soon as you go above 100, well, now if I have a virtual machine that needs 4 vCPUs, it exposes 4 virtual CPU cores. In order for any action to happen, there need to be 4 physical cores available to do the work at that point in time. And I'm ignoring hyperthreading as a complication on here, so let's just ignore that for a minute. You need to have that many cores available. If you don't have that many cores available, you have signal weight on the virtual machine. You have CPU contention on the virtual machine. And that's not too bad when you have one core web servers that aren't used that frequently. You know, you can get the feeling that, oh, I could squeeze out 120 or 130 cores on that 100 core ESX host because they're all fairly infrequently used, and I'm only using one vCPU per machine, so I can get away with that. But just slap on a 64 core SQL Server in there, and if it doesn't have all 64 available, it's not doing work at that moment, so it's waiting. And then your SQL Server gets really slow as a result, and people start wondering, well, why is the database so slow? And in that case, it's because, just like here, we're waiting for those cores to be available. So, I don't know, I guess that was my the more you know segment. But do check out signal weights when you do look at weight stats. Signal weights are particularly important for SOS scheduler yield. They're not necessarily that important for all weights. That's something that you'd have to look at on a weight by weight basis. But in this case, this is a good sign that, yeah, there's a problem here and it's around CPU. And the specific problem in their scenario was they're running standard edition. So that's limited to 16 cores. That's why I kept throwing out 16 as a number. And when you have a lot of concurrency and a lot of queries that want multiple cores, you can easily start backing up. You can see cases where a query that runs in 1 second suddenly takes 15 seconds because it's actually waiting to get enough cores to run for 1 second. Let's stop sharing now.
I'm not sure you covered that sometimes there may be spin lock contention too.
Oh, spin locks. Yes, spin locks are a thing.
Yeah.
They exist.
I've seen, in one case, which was a very long time ago, I've seen spin lock contention cause scheduler waits.
Yeah, spin locks to me are one step above fairies and elves. In that I know they actually exist, but it's rare that I see them matter.
It is rare.
That said, I hope somebody in chat is currently very angrily typing, rage typing, that yes, spin locks are important. And I'll agree. Spin locks are absolutely important. You can, with high concurrency scenarios, end up with spin locks being your major issue. And that can be very tough to diagnose. You're not going to get that with weight stats. You know, you're not going to get details on spin locks in here. You'll have to go look elsewhere for that. Yeah. So Anders asks, what is the fix? Major fix in that case, there were a couple of them. One was turning down max degree of parallelism because they had maxed op at 8 for 16 cores available. Another one is that there were a few queries that ran very frequently, which they wanted maxed op of 8. So tuning those queries, trying to make them simpler, trying to reduce the likelihood that they'll need to go parallel can help there. Forcing maxed op down on certain queries. You know, you could say, for some queries, I'm willing to let it go higher, but for this one, I want to slap down 2 or 4 because I know that it runs, and I know that it runs with some high concurrency. So now I only have to wait for 2 cores to become available. One NUMA node, not positive on that. That's a good question. Though this was a version of SQL Server that did understand automatic NUMA and could deal with soft NUMA as well if to go down that road. But yeah, basically a lot of it boils down to allow the resource to be available by increasing a bit cost threshold for parallelism, because it was at 20, which is okay, but you know, could go a bit higher. That way you're less likely to have some queries go parallel that are at that margin. If you have multi-core, parallel queries, then trying to minimize that, make the queries faster, make the queries easier, reduce the likelihood, reduce the amount of data that you're pulling in. Because if you're only getting a few dozen or a few hundred rows, you're not scanning a lot of stuff, you're not performing hash matches, you're much less likely to go parallel. You're not really going to go parallel in nested loops, for example, but you can go parallel in hash joins very easily. So those were some of the types of things that I brought up. Anders says, had one batch process where the server had to be set to max stop 1, then turned back to 8 when finished. There's a SharePoint joke in here somewhere. Yeah, if you have spend lock problems, call Microsoft support. That's not a bad idea. There are people who are qualified to deal with spend lock problems. I'm not one of them. I've dealt with quite a few concurrency issues. I've dealt with things at pretty decent scale, and I could probably fumble my way through a spend lock problem. But
I think if I recall, I think we enabled read committed snapshot, if I recall. I'm not 100% sure. It's been a long time ago, but that was one of the things.
Was that your fix?
Yeah.
Okay. Yeah, I guess I could see that. It would be,
yeah, maybe that. Yeah.
You're performing it's optimistic concurrency, so yeah. I could see it as a possibility. It was not SharePoint. No, but it could have been. Did trigger 1 million plus deadlocks on a SharePoint server after someone changed max stop to 0. So I don't understand why. Actually, I do. I understand perfect. But for the sake of a rant, I don't understand why Microsoft databases and Microsoft products are so awful at using SQL Server. You would think that, like, this is your company's product, you should know how to use it. But you look at SharePoint, you look at Dynamics, heck, look in SQL Server, you look at the SQL agent engine, you look at integration services. There are a lot of cases of databases that are really poorly designed, load procedures that are terrible. SSIS database cleanup is really bad. Query store cleanup is a train wreck. SQL agent jobs in general were a mess. SharePoint, for so long, they required max stop of 1. There's a lot of infighting. Yeah, that is a big part of it. Left hand doesn't know what the right hand is doing. Also, just because you work at Microsoft doesn't make you an expert on all things at Microsoft. It's an enormous company. Just if you're a SharePoint developer, you're not really writing in SQL. You're not really doing much there. You're a developer who got stuck having to figure out how to store the data in a SQL Server. So even if you're on the SQL Server team, you could be a C or C++ developer and have no idea how to work with SQL Server efficiently. There's it's different skill sets. So that's the real reason, at least as far as I know. Teams at Microsoft also did not previously persist past shipping. Yeah, that's a story I'm not so sure about. I believe you. I do believe you, but I never worked there, so don't know the ins and outs of who worked on what products when. Select star from master.dbo.spt_values. Yeah. Solomon mentions that's the one lookup table to rule them all pattern, where we'll just store all of our values in one table. Then we don't have to look at other tables to get any information, which doesn't work great. I'd say it works great until it doesn't, but it hits that point of doesn't very quickly. So yeah, that was wait stats, and specifically SOS scheduler yield. You're seeing that as one of your key weights. Check signal weights. If your signal weights are pretty low, essentially scheduler yield may be a benign weight. It may not be that bad. It could also indicate that you could tune some queries, but if that signal weight is really high, that's a pretty decent indication that CPU problems are there. So, next bit. Mala, you've been working with integration services for a bit.
Mm-hmm.
And you've been forced to deal with ADO.NET. So, before Mala gets into her rant, I'm just going to say that I am on record saying that Microsoft will take Oledb from my cold, dead hands.
So,
if I use integration services at all, the moment they take away Oledb, I'm done with integration services. They tried to do it back in 2012.
We have an odd environment where Kevin and I work, where one of the servers that I use in my SSIS package is on a multi-subnet AG failover cluster. And that thing, whenever that thing fails over, the package would fail because it can detect the new server name, and it uses all Oledb connections. So that's what led me to the problem, to fixing that issue, because we had to call our DBAs and ask them to fix the job whenever there's a failover, and we didn't want that to happen. Then I found that this Oledb driver didn't have an option for me with the multi-subnet failover, and the only option was actually one of our DBAs found it, that if you change the connection to ADO.NET, then that gives you an option to automatically do this. So that's when I went down this rabbit hole trying to fix all my connections to ADO.NET, and boy, it was the worst nightmarish project I've ever worked on. And then finally, I posted something on the Slack channel that some of us on, where one of our former employees and current Microsoft employee, Brian, he found a link for us that said if you updated your drivers, then you have that flag enabled for Oledb. So after 4 months of sweating this out, finally it was really simple just to update our drivers. And we didn't have an updated driver. None of us doing development had. That was another thing, that there is no easy way to know your drivers are dated unless you stumble upon something like this. So the fix was simple, but I'm not impressed by SSIS.
Yeah, by the way, if this ever hits you, here is the Oledb driver 18, and there's a fun little thing that says this page is no longer maintained. But you can go to a different page and get the latest version of the Oledb drivers. Essentially, the version of Oledb that ships with SQL Server 2019 had this flag, and we were using 2017 for those integration services boxes, so did not have that driver that had that flag. Anders says you can blame the DBAs for not keeping things up to date. Oh, but Mala admits the truth that it was actually on top. Not even on a dev server. Oh well, it was good while it lasted. The blame game works. Yeah, Oledb for life for sure. When they tried to switch over to the ODBC driver and say everybody use the ODBC driver in 2012, I tried it. It was horribly slow. I said back to Oledb. Used Oledb since. At one point, they deprecated Oledb. They said, nope, we're not going to manage this anymore. Everybody use the ODBC driver. It will be the only supported one. And my recollection is that within a few months, they undeprecated Oledb, and it is no longer deprecated because there was a lot of rioting. Because it turns out that if you actually want integration services to be fast, you kind of have to use Oledb, at least when writing bulk inserting into SQL Server. So ADO.NET, meanwhile, don't want to deal with it. ADO.NET is useful in integration services. It is mostly useful when you have to loop over a set of objects that are stored as a variable in an integration services package. So if you have an array of something in integration services, if I remember right, the only type that could actually support an array as an input was ADO.NET. You mean native client, NCI? That was deprecated in 2012 and later revived. No, not native client. Oledb specifically for SQL Server integration services. So that driver and its support within integration services was deprecated for about 1 minute. Then there were pitchforks and angry mobs burning bales of hay. Talk about tar and feathers running developers out of town on a rail. It was not a pleasant time. But in general, ADO.NET for integration services as an input is not very good. So, Malo, what kinds of problems did you have when trying to work with ADO.NET?
A, what you said, that it was very slow. I was shocked to see how slow it was. B, converting, and we have a lot of stored procedure calls and stuff that you have to pass to the procedure when you do. That was my worst nightmare, is just figuring out how to convert this thing into something that is supported by Oledb. And I did not have time to alter our control flow and everything. Like, to change the entire flow means to literally rewriting the package. That's too much work. That's not what I bargained for, and I was already well over the estimated time limit my boss had given me for this. So I was trying to make it work in the quickest manner possible, and maybe it's not designed for this either. But the stored procedure calls and the way you write queries and such, they are totally different in ADO.NET and in Oledb drivers, the way you do it. Like the silly question marks, or you call it 1, 2, 3, or you call it by name, or all these kind of things, and you spend hours figuring out how to just get a simple stored proc call to work. And to me, that was the most frustrating part of it. It's just okay. And the third one, I should absolutely say this. Third is that sometimes the data types it spits out are different than what you get with Oledb.NET. So you need to add additional mappings and conversions and all that for that.
Yeah, it's just there's a lot of difference. And ODBC was a bit easier to work with. It was just dog slow. So following up on Solomon, native client, I guess native client, the Oledb driver for working with .NET is still deprecated, but Oledb driver for SQL Server that is used mainly for integration services became undeprecated in 2017. So it actually was technically deprecated longer than I remembered, but frankly, Oledb was still used in SQL Server 2012, 2014, and 2016. So I used it all throughout those years. Andrew says, don't you know that BIML is the answer to all integration services problems? I still like BIML. I still like BIML. It's interesting seeing Verigent's maneuvering in an Azure Data Factory world where integration services is not exactly hot technology. It's still useful enough, but it is definitely on the downswing in terms of technology curve. Like I would still expect to see integration services packages a decade from now, but I would not expect to see many new projects using integration services a decade from now. And the ones that do have crusty old people like Anders, except who like integration services. There's your counter dig. They have some people who spent so long in that product that they just don't want to give it up. Sort of like how, say, 15 years ago, you still had DBase 4 people hanging around trying to do everything in DBase. It's same story. Or the Lotus Notes people who still wanted to do everything in Lotus Notes. Still use BCP. Well, BCP is still supported. I know that in Azure Synapse Analytics, BCP is out,